So in our next lab, we're going to be mixing cornstarch and water together, and we're going to be looking at the idea of, is it a liquid, is it a solid, or maybe does it have properties of both a liquid and a solid? And then we're going to take that and we're going to compare it to what's going on inside the mantle and connect it back to our unit with plate tectonics. So in this lab, you're going to need some cornstarch and you're going to need some water. So you're going to want 2 parts cornstarch to 1 part water. And it doesn't matter how much of this you make as long as you have enough of it to see the experiment. So in the video that I'm going to show you, I used about a teaspoon or a tablespoon worth of cornstarch. You can make more of it definitely if you would like, but you don't have to have a whole lot of it. And then you're going to just half the amount of water that you had cornstarch. So for example, if you used half a cup of cornstarch, you would only want to use 1/4 a cup of water. And then what you're going to do is you're going to mix your cornstarch and your water together, and you're going to kind of knead it together, and you can kind of knead it on the table as well. And you're going to just mix those 2 ingredients really well. And when you do that, I want you to clump it up off of your table, and I want you to kind of open up your hands and let it flow out. This experiment is a little messy, so you do not want to do this on the floor or on furniture. You definitely want to do this on a countertop or a table that is easy to clean. And so in this next video, you're going to see my mixed product and kind of that clumping action, picking it up and then watching it kind of flow out of your hands as well. Okay, so in that video, you see that I'm able to pick up the cornstarch water solution like it is a solid. But then when I open up my hands, all of it is just going to flow out like it's a liquid. So we see this idea that an item or a substance can have properties of both a liquid and a solid. And that's really what we're seeing in our mantle. So we have our core, and at the core, this is very hot. And then we have our crust. And remember that the crust is very cool. And then in between that, we are going to have the mantle. And the mantle is where we have magma that is going to have properties of both a liquid and a solid. And that's what's going to allow for these convection currents inside of the mantle to occur. And when convection currents occur inside the mantle, we have the hot fluid rising from the core to the crust, but as it's reaching the crust, it starts to cool off. And so in our convection demo, we saw that as it starts to cool off, it's going to gain density and then it's going to sink back down. And so this is going to occur several different places inside the mantle, and this is what's going to create plate motion, because we can see here that this arrow is going this way and this arrow is going this way. And so this area right here is going to be a convergent boundary because I have 2 parts of the mantle kind of convecting towards each other like this. And so that's going to cause a convergent boundary. We could also see areas where we have a divergent boundary where we have these convection currents. This arrow is going this way. This arrow over here is going this way, and so it's pushing apart, and that's going to be a divergent boundary. And this is all occurring because inside the mantle, it is going to have properties of both a liquid and a solid, which is what is going to allow for these convection currents to occur in the mantle.